Hi everyone. Today we will discuss functions, domain and range. To describe these concepts, let us take two parameters, suppose y as well as x. Now when we take this y and x, so here there is no relation between y and x. We can take any value of y. Suppose if you want to take 1, you can take y is equal to 1, you can take y is equal to 2, you can take y is equal to 3 and so on. And similarly, you can take x is equal to any value. That depends on your choice. We can consider x is equal to 5, we can take x equal to 6, we can take x equal to 7 and so on. So here we have taken y is equal to 1. It is not necessary that we should take x equal to 1. We have taken y is equal to 2. It is not again mandatory that we have to take y is equal to 2 and so on. We are free to take any value of y and we are free to take any value of x. It means this only implies that there is no relation between x as well as y or y as well as this x. Now suppose you take y is equal to x. Put this equality sign. Y is equal to x. Now if you take y is equal to 1, you have to take x is equal to 1. If you take y is equal to 2, you have to take x is equal to 2. It means we have to now take the values of x corresponding to this y, maintaining this equality sign between these two. So y is equal to 1, we have to take x equal to 1, y is equal to 2, we have to take x equal to 2 and so on. So it means now x is not independent. Here x is independent as well as y is independent. Here y is still independent, but now x is not independent. X is now depending on y. Because if we take y is equal to 1, we have to consider x equal to 1. Or if you take x equal to 1, we have to take this y is equal to 1, vice versa. So it means here one is behaving as an independent variable, another is behaving as a dependent variable. Here both are behaving as the independent variable. When we use the word variable, it means we are free to take or assign any values for y or any value for this x. But now once we have this equality, that is y is equal to x, so one is still behaving as independent variable, another is behaving as a dependent variable. Now here both of them are independent. Here if you say x is independent, then y is dependent. If we take x is equal to 1, we have to take y is equal to 1. If we take x equal to 2, you have to take y is equal to 2, or you will get y is equal to 2. If we take x equal to 3, we will get y is equal to 3 and so on. It means still x is independent, but y is not dependent. It depends on the value of this x, the value that we choose for this x. So it is independent, this is dependent. The value of independent value. Now independent or dependent, that has come into picture because of what? Because of this equality sign. So just this equality has related these two parameters, y as well as x. There was no relation between this x. Here this equality has related this y and this x. So any rule or any regulation, any method through which two parameters get related, that is termed as the function. So now y is a function of x. Now we will say y is a function of x because y is depending on x. So any rule, any relation, any method which relates two parameters, that is termed as the function. So we will now call it as y is a function of x because y is depending on x. So y is depending on x, y is a function of x. Here function word is used, its first letter is f, so we will call it as function of x, and it can be represented as y is a function of x. You can also represent it as y is a function of x, or we can also write y is equal to f of x. These are the various ways that we can represent y is a function of x, f of x, y is a function of x, and y is a function of x. These are the various ways that we represent that y is a function of x, means y is depending on x. So that gives you the concept of this function. Now the second term is this domain. Domain simply means the values of this independent parameter. Independent and dependent parameters, it can be interchanged. Suppose here, if you write the equation as x is equal to y, So if we take x is equal to y, so here if you take y is equal to 1, you have to take x equal to 1. If you take y is equal to 2, you have to take x equal to 2, and so on. It means here y is behaving as an independent variable, x is behaving as the dependent variable. So they can be interchanged. Either you write x equal to y or we write y equal to y. But when you write x equal to y, you will get x is a function of y. Here x is a function of y, f of y. Okay, x is a function of this y. So that way we have to see this configuration and we have to consider. Now, the values of this independent variable, this x is your independent variable, the value of the independent variable for which the function f of x, or this y is defined, is termed as domain of the function. The values of the independent variable, whether you take this relation or you take this relation, considering whichever parameter you are taking as dependent or independent. The values of the independent variable for which the function f of x or the function fx or y is defined is termed as domain of the function. And the corresponding value of y or the corresponding value of f of x, that is termed as range of the function. So values of x here, if it is an independent variable, that will, for which the function is defined, is termed as domain, and corresponding value of y, it will be termed as the range of the function. Now again we are getting another term, and that is called defined function. Defined function. So what are the defined functions? Which function is defined? Which function is not defined? How we consider and how we analyze? Because based on this only, we will get the values of x and the corresponding value of y. The values of x for defined function, it will be termed as the domain of the function, and the corresponding value of y, that will be termed as the range of the function. Now what are the conditions that makes a function defined function? So let us see that. Now see this defined function. These are the three conditions as far as the defined function is concerned. If any function, suppose if you have any function f of x, now for real values of this x, you take real value of x. For real values of x, if y or f of x is also real, we have taken real values of x, and f of x or y is also real. In that case, this gives you the condition, the first condition for the defined function. Second condition is if x is finite, you take finite value of x and f of x or y is also finite. Okay, then only we can say that it is a defined function. Third condition is for no values of x, y or f of x should be indeterminate. It should not be an indeterminate means it should not come in the form of 0 by 0, infinity by infinity, infinity minus infinity, and so on. There are 7 forms of indeterminate function that we will just see. So for no values of x, we should not take any value of any such value of x for which y or f of x becomes indeterminate, or it takes the form of 0 by 0, infinity by infinity, infinity. Because we can't calculate the values of such forms. Once it is in the indeterminate, as the name suggests, we can't determine the value. So we can't say that 0 by 0 is 1 or 0 by 0 is 0. We can't say infinity by infinity, as we say 1 by 1 it is 1, 2 by 2 it is 1. So according to that logic, 0 by 0 it should have been 1. Infinity by infinity it should have been 1. But there is another logic, any quantity, any finite quantity divided by 0, that becomes infinity. Any quantity divided by infinity, it becomes 0. So based on this, it should be equal to what? Infinity. Based on that concept that any quantity divided by infinity, it becomes 0. So it should be equal to 0. But it does not happen. That's why there is confusion. There are some complexity involved in this. And that's why we put some quantities or some forms of this mathematical calculation in the indeterminate form. So they are some of the examples of the indeterminate form. So we should not consider any value of x in the domain of the function f of x such that the function f of x or this y should become indeterminate. Now these are the three conditions. If these three conditions are satisfied simultaneously, then only we say that the function f of x is defined, otherwise it is a non-defined function. Yani, if x is real, y should also be real. If x is finite, y should also be finite, and we should not consider any value of x in the domain of the function for which y or f of x becomes indeterminate, or it takes the form of indeterminate form. So these three conditions must be satisfied. Okay, and if these three conditions are satisfied simultaneously, we say that the function f of x is a defined function. Whatever values of x justifies that defined function will be termed as the domain of the function, and the corresponding value of y or f of x, it will be termed as the range of the function. Now, as far as calculation of domain or range of the function is concerned, we don't have any particular rule or method to calculate the domain of the function or range of the function. Calculation of domain of the function or range of the function, it completely depends on two conditions. One is the definition of that function, under which interval that function is defined, or under what conditions that function is defined, and another is these three conditions. We will always keep in mind these three conditions whenever we want to calculate the domain or range of the function. Once you keep these three conditions in your mind, then only you will be able to calculate the domain of the function or range of the function. Because we don't have, this is not a mathematical rule to apply this rule and calculate domain or calculate the range. We have to see the nature of the function for which we have to calculate the domain of the function or range of the function. We have to keep these three conditions in our mind, use these two concepts, and you will be able to calculate the domain of the function or range of the function. Now let us see all these indeterminate forms. There are 7 forms as far as these indeterminate forms are concerned. 0 by 0. So if you consider this 0 by 0, so 0 by 0, just for example, as I have just told you, if you take x square, limiting value of x square minus 1 upon x minus 1 when x tends to 1. So when x tends to 1, if we put this, so 1 minus 1 it is 0, 1 minus 1 it is 0, that becomes 0 by 0. So we can't calculate the value of this. We can't calculate the value of the function f of x is equal to x square minus 1 divided by x minus 1 at x is equal to 1. Because at x equal to 1, the numerator is 0, the denominator is also 0, and it attains the form 0 by 0, which is supposed to be indeterminate. And that's why we can't calculate. Again, in the next classes, we will be understanding the concept of limits. So because of this indeterminate form only, we have the concept of the limit. That is the need, that we can't calculate its value at x equal to 1, but we can calculate its value at what? x1 plus or x1 minus, something more than x or something less than this x is equal to 1. Then 1.0001, if you consider, it is not indeterminate at that point. Similarly, if you want to calculate its value at 0.99999, so again we can calculate it, it is not in the indeterminate form. Calculating value at the approaching value, like x tends to 1, when we say x tends to 1 means either 1 plus or 1 minus, more than slightly more than 1 or slightly less than 1. So there we get the concept of this limiting value, and that we will study in the coming classes. So here, so it is in the 0 by 0 form at x equal to 1. Similarly, if you consider this, infinity by infinity, so limit x log of base ex upon x. When x is infinity, so denominator is infinity. Log of infinity, it is also infinity. So this is again in the form of infinity by infinity. So again, if you want to calculate, again we have to consider the limiting values, how to calculate the limiting value. Then only we can calculate or simplify this. Otherwise, it is in the 0 by 0 form. Similarly, limit x tends to pi by 2 minus x tan x. Pi by 2 minus x, when x is pi by 2, that becomes 0. Tan pi by 2 is infinity, so it is in the 0 into infinity form. So first form is 0 by 0, second is your infinity by infinity, third is 0 into infinity. Other form you can see Fourth is infinity minus infinity. Again, you can take this example at x equal to 1. This is infinity, and again it is also infinity. So this is in the infinity minus infinity form. Again, sine x to the power 10x, sine pi by 2 it is 1, and 10x 10 pi by 2 it is infinity. So this becomes 1 to the power infinity form. Again, sine x to the power 10x, sine pi by 2 it is 0. Sorry, yeah, sine x tends to 0. So sine 0 it is 0, tan 0 it is also 0. So it is in the 0 by 0 form. Cot x to the power sine x, again when x tends to 0, this is infinity. Cot x when x is 0, it is infinity. Sine x it is 0. So it becomes your infinity to the power 0. So these are the 7 forms: infinity to the power 0 to the power 0, 1 to the power infinity, infinity minus infinity, and 0 by 0, infinity by infinity, 0 into infinity. So these are the various forms as far as the indeterminacy of the functions are concerned at particular points. So it means now again, if you summarize this, so here for no, if x is real, this y should also be real. Okay, and y or f of x. If x is finite, this f of x should also be finite, and we don't have to consider any value of x in the domain of the function such that y or this f of x becomes indeterminate. So we need to follow these conditions, and we need to follow the nature of the function. Only these two things you have to analyze. Follow the nature of the given function, for which we need to calculate the domain as well as the range of the function. Keep these three conditions in mind and you will be able to calculate the domain and the range. So particularly we don't have any method. Third thing that you will need in calculating this domain or range of the function, this inequality. Sometimes you will get, let us say, x minus 2 into x minus 3 is equal to 0. So this is your equality. If you want to simplify this, your answer will be x equal to 2, x is equal to 3. But if it is in the inequality form, let us say x minus 2 into x minus 3 less than equal to 0, then how to simplify this? So if you consider this into this less than equal to 0, you will have various conditions. If this is positive, this will be negative, or if this is positive, this will be, if this is negative, this will be positive. So you have to analyze all this. X minus 2, first case if you take, x minus 2, it should be positive, means greater than equal to 0, so you will get x greater than equal to 2. X minus 3 less than equal to 0, I am taking negative, so x less than equal to 3. Again, you have to analyze that. Again, second case, x minus 2 less than equal to 0, minus sign I have taken, so x less than equal to 2. X minus 3 greater than equal to 0, because positive we are taking, so x greater than equal to 3. Now you have all these various solutions and you have to find the common solution out of this. After combining all these cases and considering all these cases, we come to this conclusion, and let us generalize this. X minus a into x minus b less than equal to 0. X is your variable, a and b are constants. Now out of these two constants a and b, suppose a is less than b. Let us say here constants are your 2 and 3. So 2 is less than this 3. So any of these two constants, one will be less than another. So we are assuming a is less than b. Under this condition, if you see this inequality, x minus a into x minus b less than equal to 0, so your solution is that x lies between a and b. X lies between these two constants, yani greater than the smaller constant and less than the larger constant, because we have assumed a less than b. So directly you can write x lies between a and b. There is no need to analyze so much again and again. This is a foolproof concept. Once you consider this condition should be satisfied, then just choose which constant is smaller and which constant is larger. So smaller it will be treated as your a, larger it will be treated as b, and then you can consider x lies between a and b. If it is greater than equal to a, then x does not lie between a and b. X is less than equal to a and x is greater than equal to b. If you want to understand it on the number line, so suppose this is your 0, a is less than b. So somewhere you have a and somewhere you have b. This says x, under this condition we get x lies between a and b. X lies between a and b means x is greater than equal to a but less than equal to b. So x is lying between this, so only within this, right? So this is the interval for this x. Second case, if you consider x is less than equal to a, x is greater than equal to b, less than equal to a, and in this side, less than this a, and greater than this b, and in this side. And it does not lie between a and b. It goes from b to infinity, and it goes from a to minus infinity, but it does not lie between this a and b. So we can directly use this relation to simplify the inequalities. If you have this kind of inequality, if you come across this, so directly you can use this and just put your answer. Now just to take some example, just to calculate the domain of the function, let us take some example. Suppose square root of x squared minus 4. We have this y. Y is equal to square root of x squared minus 4. We want to calculate the domain of this function. Now, domain of this function is to be calculated. Now see, what are the things that you have to keep in mind? We don't have any rule to what should I do to calculate the domain. So you have to think the nature of the function as well as those three conditions. Now nature of the function is, here it is your square root function, here it is simple algebraic function. Now based on this, we will try to analyze the square root function. We know that first let us start with the square root function. From outer function towards the inner function. So your outer function is the square root function, your inner function is this simple algebraic function, that is x squared minus 4. With this we will try to get the clue based on the nature of this function. So square root function. Now anything under square root, if it is negative, from the property of the square root function that we know, as well as from the property of the real number as well as the imaginary number, we know that anything under square root, if it is negative, that becomes an imaginary quantity. And what is the condition for our defined function? For real values of x, y should also be real. It means this y should not be imaginary. If we take any real value of x here, corresponding to that, this y should not be imaginary. Now, this entire function is under this square root. If the value of this function for any value of x, if it becomes negative, then we will have to calculate the square root of that negative quantity. And the square root of that negative quantity becomes what? Imaginary. And imaginary, it is not part of the defined function. So it means what clue we are getting? The square root of this, it means it can't be negative, it has to be positive. So from there we got the clue that x squared minus 4, it should be greater than equal to 0. Now once you get this inequality, just simplifying this inequality, you will get what? Value of x, and that value of x is the domain of the function, because now that will meet the condition of what? The defined function. Defined function says for real value of x, y should be real. So we have taken the value of this x squared minus 4 in such a way that it should be a positive quantity. And once it is a positive quantity, then we have to calculate the square root of that positive quantity. And the square root of that positive quantity, we know it will be real. So in that case, y will be real. So this is the required condition, that it should meet all the required conditions for a defined function. So x squared minus 4 greater than equal to 0. There are no terms in the denominator. That means if suppose some terms are in the denominator, let us say y is equal to 1 upon x. So if you take x equal to 0, then this will become infinity. Y will become infinity if y is equal to 1 upon x. In that case, again the second condition says for finite value of x, y should also be finite. It means that value of x 0 here, it is not part of the domain of the function y is equal to 1 upon x. Here similar terms are not there in the denominator. That's why we are not bothered whether x is equal to 0 or x is not 0. If some of the terms would have been in the denominator for which y becomes infinity, then those terms will we'll have to eliminate. We have to eliminate those terms for which y becomes infinity, because that is also not part of the defined function. But here we don't have any confusion regarding that. We don't have any tension regarding that it may become infinity for finite value of x. So we need not go for that requirement. So here this is x squared minus 4 greater than equal to 0. Now let us simplify this inequality. Again, just to simplify this inequality, we have to convert it into linear function. So because it is a quadratic function, so let us change it to linear function. So factorize this. So this will be x plus 2 into x minus 2 greater than equal to 0. Now you can see this. We have factorized into linear function, so we can make use of this, because here it is greater than sign. Out of this plus 2 and minus 2, just identify which is behaving as A and which is behaving as B. A means the smaller, B means the larger, that nomenclature that we have used here. Standard form is minus sign here, minus sign here. So put it in the standard form, x minus minus of 2 into x minus 2 greater than equal to 0. X minus A, x minus B. Minus 2 is less than this 2. So minus 2 behaves as your A and 2 behaves as your B. So minus 2, it means x less than equal to A, x greater than equal to B. So your solution will be x less than equal to minus 2 and x greater than equal to 2. X less than equal to minus 2 and x greater than equal to 2. It means x does not lie between minus 2 and plus 2. Otherwise, it has the domain of all numbers from 2 to infinity as well as minus 2 to minus infinity. If I can put it on the number. This is your minus 2 here and this is suppose plus 2 here. 2 to infinity. So all values from 2 to infinity and all values from minus 2 to infinity and all this. So this is part of the domain, this side, and this is part of the domain. So it means x less than equal to minus 2, x greater than equal to 2. So this way we can calculate the domain of the function. Similarly, we can calculate range of the function. So we will take more and more examples in the coming class. Thank you.